Good morning, class, and welcome to Graphing Linear Equations, Chapter 4.2. And there's many ways that you can graph an equation. In this chapter, we're going to see a couple different ways. So today, we're going to talk about the first way that you could graph an equation. So let's get started. Verifying solutions of an equation. This is the first thing we're going to kind of dive into is decide whether the point lies on the graph of x plus 3y equals 6. Justify your answer algebraically. Now, if I was going to graph this, okay, in our coordinate plane, okay, would these 2 points lie on there? And if I graphed it, in my coordinate plane, okay, I could, use our ordered pairs, 1, 2, and notice that, 1, 2, okay, that doesn't lie on the line. Now I just made this line up, but you kind of see my point. We're trying to see, but how can we justify that algebraically? So remember that the ordered pair is x, y. So we're going to plug in that x and that y into our equation. So first let's work with the ordered pair 1, 2. So 1 is our x, so we'll plug it in, plus 3 times 2 equals 6. So we know that 3 times 2 is 6, so 1 plus 6 equals 6, which 7 equals 6, which that is not true. So we know that 1, 2 does not fit or lie on that line. Okay, so this is how we're proving it algebraically right here. Okay, so let's try negative 3, 3. So we plug in negative 3 for x, plug in 3 for y, and you get 6. So negative 3 plus 9 equals 6. Negative 3 plus 9 is 6, so 6 does equal 6. So this checks out. So negative 3, 3 does lie on that line. And this is how we check it algebraically. We plug in the x, we plug in the y, and then we hope we get the same number. Okay, kind of similar to what we saw last chapter when you got the same number on both sides. We know that that ordered pair lies on the line if we graphed it. So graphing an equation. So use a table of values to graph the equation y equals 2 plus 3x. So step 1, rewrite the equation in function form if necessary. Isolate the y. So very important, which we'll talk about at another time, but y equals mx plus b. This is called slope-intercept form. I'm not too worried about you jotting this down right now, but just so you know, because it says write the equation in function form. Function form means you're going to isolate the y. So the first thing we have to ask ourselves, is the y alone in our equation? And it is. So y equals 2 plus 3x. Then you're going to choose a few values of x and make a table of values. So here's our x values, negative 2, negative 1, 0, 1, and 2. And now you got to pretend like this is an ordered pair. Okay, we're trying to figure out our y value in our ordered pairs. So we picked our x value, and now we have to select our y value by plugging these in. So this is where the algebra comes in. We know that negative 2 is our x, so y equals 2 plus 3 times negative 2. So y equals 2 plus negative 6. So 2 plus negative 6 equals negative 4. So we know our y value here is negative 4. So negative 2, negative 4. So now plug in negative 1. Y equals 2 plus 3 times negative 1. So y equals 2 plus a negative 3, which y equals negative 1 then. So negative 1, negative 1. Plug in 0. Y equals 2 plus 3 times 0. Well, we know that 3 times 0, anything times 0 is 0, so 2 plus 0 is 2. Okay, so now after you've done 3 points, you will see a pattern here. we see that this will increase by 3, increase by 3. So we know automatically that if you plugged in 1, you should get 5. If you plugged in 2, you should get 8. Okay, so here is my table of values. Okay, so again, let's go over this. Step 1, rewrite it in function form, meaning isolate the y, get the y alone. Step 2, choose a few values, which we did, -2, -1, 0, 1, and 2, and make the table, which we did here. And now we're going to plot the points. So, okay, so we have our points now, and we're going to plot them. So -2, -4, -1, -1, 0, 2, 1, 5, and 2, 8. Now, when you're solving these algebraically and you plug in your answers, you know, let's say instead of 2 here, let's say I got, 4. And I went to 0, 4. Okay, you could see that my line wouldn't be as straight if I was going like this and then had to go up here and then back over. Okay, it's not as straight, so you could see that. Okay, so the line must be straight. Okay, that's not a very good straight line, but you see my point that it must be a straight line. So if you notice a point and it makes your line jagged, doesn't make it straight, then we did something wrong algebraically. So graph the equation 3x plus 2y equals 1. Use a table of values. So remember, step 1, we're trying to isolate the y, and y is not alone here. So step 1, 3x plus 2y equals 1. So we're going to subtract 3x. So 2y equals -3x plus 1, and divide by 2. So y equals -3x plus 1 over 2. Okay, now step 2 tells us to pick our values. So let's select x and y. And for this one, let's choose -2, -1, 0, 1, and 2. Let's use the same values. So now we're going to plug those in. So if we plug in -2, we know that -3 times -2 plus 1, well, that is 6. 6 plus 1 is 7. 7 over 2. Or you can put 3 over 5. Whatever you would prefer to put. 7 over 2 or 3.5. So plug in -1 now. I'll do the work up here. -3 times -1 plus 1 over 2 equals 3 plus 1 over 2, which equals 4 over 2, which equals 2. So plug in 0. We know that -3 times 0 plus 1 over 2, which equals 1 over 2, because 0 times 3 is 0. So a half. So let's see if we can see a pattern here. This decreased by 1.5. This decreased by 1.5. So we can decrease again by 1.5, and you'll get a -1. If you plugged in 1 here, just think -3 times 1 is -3 plus 1 is -2. -2 divided by 2 is -1. And then we decrease by 1.5 again, so we're hoping that we get a -2.5 here. Okay, so we could check it just to verify our answer. -3 times 2 plus 1 over 2, which is -6, plus 1 over 2, which is -5 over 2, which is -2.5. So we made our function. We made our table of values, and now we have to graph these points. So -2, 3.5, -1, 2, 0 and a half, 1 and -1, and 2 and -2.5. So we can see that we have a decreasing line here from left to right. Okay? After we plot points, make sure that our line is straight. Make sure these points line up to make a straight line. And that's my son Noah. Can you say hi to my class?
No.
No? Okay. Alright, horizontal and vertical lines. In the coordinate plane, the graph of y equals b is a horizontal line. In the coordinate plane, the graph of x equals a is a vertical line. So when we say graph y equals 2, that tells me for every ordered pair, the value on the y is 2. So any number that I plug in, my y will be a 2. So I can plug in -1, I can plug in 0, I can plug in 6. So when I graph this, -1, 2, 0, 2, and 6, 2, okay, I can see that this is a horizontal line. So again, when it's just y alone, there's no x value, okay, in the equation, okay, you know that you will have a horizontal line. Okay, so the y equals 2 tells me that for every ordered pair, your y is 2. So the same thing kind of for the x equals -3. For every ordered pair on this line, your x will be -3. So I can plug in any value that I need to. And I can see that -3, 1, -3, 3, and -3, 6. Okay, gives me a vertical line straight up and down. Okay, so think about that. When it's just x equals -3 does not have a y within the equation, you know that your x value for every ordered pair will be -3. Okay, same for the y. When it's y equals no x value, you know that all your y values will be 2. Okay, and then you just connect the dots. So here's your homework. Graph 4x plus y equals 8. Graph 3x minus 2y equals 6. And then graph y equals -3 and x equals 2. Okay, remember, go through each of the steps. There's 3 steps to solving these problems right here. Okay, get it to y equals 4 first. Okay, make sure the coefficient on the y is positive, especially right here. Okay, and then plug in values for your x and y, and then plot those points. If you have any questions, please feel free to email me. I hope you have a wonderful weekend, and I'll see you in class on Monday. Take care.